Okay guys, so this is a little bit different from what we're used to. You've been given a note-taking guide. It looks just like what you see on the screen here. So I'm going to try writing on this note-taking guide here on the screen, and you can fill it in with me as we go. Of course, you can pause the video anytime you need to catch up, and we'll see how this works. Alright, so first of all, today you're going to be solving radical equations. We've simplified radical expressions. We've graphed radical equations. So now we're going to actually solve radical equations. So what is a radical equation? It's a radical equation is an equation with a radical that has variables and I'm writing variables. It could be a variable in the radicand. And we remember that the radicand is the part that's under the radical sign. So to solve a radical equation, we follow these steps. First, isolate the radical on one side of the equation. So if you've got something like a k value that's outside of the radical that you need to subtract or add, you do that first. Then if you need to divide an a value that's on the outside of the radical, you do that next. So you want to get the radical by itself, and of course we'll be practicing that. Then you raise each side of the equation to the same power in order to eliminate the radical. So if it's a cube root, then you would cube both sides. If it's a fourth root, you would raise both sides to the fourth power in order to get what's under the radical by itself then, not under the radical anymore. And then finally, you're going to solve the equation that's remaining, which will be a polynomial. It might be linear, it might be quadratic, it might be cubic, okay, as we've done before. Alright, so here would be an example. Here's our radical, and already we can see the radical is here on the left, and we don't have to isolate it because it is already isolated. There's nothing with it. And I kind of don't like what I drew there, so I'm going to erase that. Okay, so now the next step, since it's the radical is already isolated, there's nothing added outside, there's nothing multiplied outside, we're going to square each side. And the reason we square is because this is a square root, so the inverse operation would be to square. And we actually did this in the quadratic unit. So when we square the square root of x plus 6, here on the left, we get x plus 6. On the other side, when we square 3, we get 9. But, okay. So then the last step, of course, would be to subtract 6 from both sides, which would give us x plus 6, or x, I'm sorry, x equals, well, we can write it this way, x plus 6 minus 6 equals 9 minus 6. And then these note-taking guides are sometimes a little goofy. And then, so that's 0, so we get x equals 3. So the solution is 3. And you would check that back in the equation. Okay? So down here at the bottom is a problem for you to practice on your own. So at this point you can pause the video, work the problem out on your note-taking guide, and then when you unpause the video, then I will solve it with you so you can see if you did it right. Okay, so coming back together then, my first step is I want to get this radical by itself. I want to get that part by itself, so I'm going to subtract 1 from both sides, which gives me the cube root of x minus 5 equals negative 1 minus 1 is negative 2. Be careful with those little computations. Sometimes we mess those up. Okay, and so now that I have that, I want to use my inverse to uncube this. So the inverse of cube root is to cube, which then gives me on the left x minus 5. And when I cube negative 2, I get negative 8. So my last step is to add 5 to both sides, which gives me x equals negative 3. And that is my solution. Alright, so moving on. We're at the top of the second page now. So now, related of course to radical is the rational exponent. So we're going to solve when there's a rational exponent. So here's our original equation. Now the thing is, a rational exponent, remember, is a radical. So we would want to isolate that part. Well, it's already isolated because the root of that exponent is the parentheses. It's raised to the 2/3 power. Now here's what we do. Watch this. It's pretty cool. So we take our 3x plus 4 to the 2/3 power, and we use our power of a power rule. And our power of a power rule says that when we have a power and we raise it to a power, we multiply the powers together. Okay, so that's nice. The other thing that we need to remember is that what a reciprocal is. So reciprocal, and I'm writing it over here on the left, when we have a fraction, its reciprocal, you could say, is just flipped upside down. Okay, well that's good. But the real definition of a reciprocal are numbers such that when we multiply them, the product is 1. So when I take 2/3 times its reciprocal of 3/2, I get 6/6, which equals 1. Okay, so what does that have to do with our equation? Let's go back to our equation. I'm going to use my power of a power rule, and I'm going to use my reciprocal idea, and I'm going to take this side of the equation and I'm going to raise it to the reciprocal power. So the reciprocal of 2/3 is 3/2. Well, of course, this is an equation, and what I do to one side, Okay, guys, so at some point in this process, I paused the video, and honestly, I've gotten lost in it, and I don't want to start over. So if you've already seen this part, I apologize. You can just skip past it. Okay, so I'm going to take care of this little example checkpoint that you did down here. So I start by subtracting 1 because I want to isolate that radical. And then the inverse of cube root would be to cube. So I'm going to cube both sides. And be really careful with that negative 2. So over here on the left, when I cube the cube root of x minus 5, I get x minus 5. And when I cube negative 2, remember that's negative 2 times negative 2 times negative 2, which is negative 8. So when I add 5 to both sides, I get x equals negative 3. And that is our solution, negative 3. We can check that by putting it back into the equation. I'm not going to do this every time. It's a good idea, but I don't want to take the time on the video, but I want to make sure to show it to you once. So we have the cube root, and I'm going to put negative 3 in for x. And then I'm going to simplify what's under the radical. Negative 3 minus 5 is negative 8. The cube root of negative 8 is negative 2. And negative 2 plus 1 is negative 1. Negative 1 equals negative 1, so my solution checks. Alright, so now we're on to this next example, and this next example is an important one because now we have, instead of it being written in radical form, our equation is written with a rational exponent. And so there's a couple little things we have to take note of. First of all, the exponent is outside the parentheses. So the base of the exponent is 3x plus 4. All right? That's all in there. And the first thing we want to do is actually get rid of this rational exponent. That's how it's like getting rid of the radical sign. So the way to do that, we have to remember what reciprocals are. So given the fraction 2/3, its reciprocal is 3/2. And if I multiply these reciprocals times each other, I'm going to get 6/6, which is 1. And that is actually the definition of a reciprocal. Numbers such that when multiplied together, the product is 1. So now I can take my, well, I guess I should write it down here. I can take this quantity 3x plus 4 to the 2/3. Oh my goodness, I did not mean for that to happen. To the 2/3 power. Having a little trouble here. And I can raise it to the reciprocal power, which is the 3/2 power. Now, of course, being an equation, if I'm going to raise the left side of the equation to the 2/3 power, I have to raise, or 3/2, I'm sorry, power. I've got to raise this 16 also to the 3/2 power. Don't forget the first commandment of solving equations. What you do to one side, you have to do to the other side. So over here on the left, which is kind of a mess, I apologize, but when I multiply, when I raise my power to a power, which is my rule of exponents that I learned, I multiply them. So when I multiply these two exponents, I get 1. So now I have 3x plus 4 to the first power, which is just 3x plus 4. And then on the other side, 16 to the 3/2 power. You can simplify that in your calculator, or just think about it. I'm going to come over here and do this. 16 to the 3/2 power is the square root of 16 cubed. Well, you know the square root of 16, it's 4. And 4 cubed is 64. So our answer over here is 64. So there we go. Now it's easy. Now we're just going to subtract 4, and I don't know, these note-taking guides, it seems like so often they have extra steps on them, so I'll just, recopy this here. So I'm going to subtract 4 from both sides, so I can get my x term by itself, so 3x equals 60, and then divide both sides by 3, and I get x equals 20, and my solution is 20. And you can check that the same way we did on the other page by putting it into the original equation. Okay, I'm going to stop this video at this point because I can only make them so long, and because that's all the app will do. And I'll save this one, and then we'll pick it up at example 3 in the next video.